Ladies and gentlemen, good afternoon and welcome to European Coatings Live, the monthly web event of the European Coatings Journal. My name is Damir Gagro and I am editor at the European Coatings Journal. It will be my pleasure to guide you through this event today. For those who don't know it yet, what is European Coatings Live? European Coatings Live is meant to provide you with in-depth information on hot topics that are discussed in the coatings industry and the European Coatings Journal. Moreover, European Coatings Live offers you the unique opportunity to get in touch with our speakers, pose your questions, join the discussion, and receive immediate solutions. European Coatings Live means interaction, so please don't hesitate to express your views. The focus topic of this current issue of the European Coatings Journal is wood coatings. Today, Dr. Gerhard Gröhl of Holzforschung Austria will talk about 2 decades of research into the durability of exterior wood coatings. The presentation is based on his technical paper in the current September issue of the European Coatings Journal. But before we start with the presentation, I would like to draw your attention to some features you can find on your screen. You can see logos of our sponsors who have also advertised in the current issue of the European Coatings Journal. Also, there's a box to drop your question at any time of the presentation. I will collect all questions, and after the presentation, we will discuss them with our speaker in order to supply you with an immediate solution to your problem. And now, it's my pleasure to introduce our speaker to you, Dr. Gerhard Gröhl. He is a graduate of the Department of Wood Economy at the University of Natural Resources and Applied Life Sciences in Vienna, Austria, and head of the Department of Wood Preservation and Bioenergy at Holzforschung Austria. He is a member of the CEN TC139WG2 coating systems for wood, and since 2009 chairman of the Austrian Standards Committee ASI K050 coating materials. He's also a lecturer at the University of Natural Resources and Applied Life Sciences in Vienna. His work focuses on coatings for wood, wood damage, and wood anatomy. Hello, Mr. Gröhl. How are you today?
Hello, Mr. Gago. Thank you very much for your kind invitation. I'm fine.
So then, we don't want to let our viewers wait. The screen is all yours. Please start your presentation.
Thank you very much again. Dear ladies and gentlemen, it's my pleasure now to give a talk on this European Coatings Live channel this afternoon. And I'm going to talk about wood coatings, and I'm very happy about that, not only because I'm a wood technologist, as you heard, but in times like this, there was a decision that we had to postpone the upcoming PRA's Wood Coatings Congress, which was planned for October this year in Amsterdam, and it will be postponed until next year. So in particular now it's a pleasure to talk about wood coatings and to have that as a focus issue in September this year. In my presentation, I want to report on 2 decades of research on durability of exterior wood coatings, and I want to reflect a bit critically our work that we've done in these 2 decades and whether we have gained real long-term experience. And when you're considered with exterior coatings, you know that long-term experience is something everybody wants to have. The question is, what is enough experience that you can say that you've got long-term experience? So let's see what we have done in the last 20 years. Why 20 years? It's kind of anniversary. I started working here at the Institute with my research group on wood surfaces around the year 2000. And we've been working on all applications for wood coatings in interior and exterior applications, but with particular focus on exterior wood and with also particular focus on durability in exterior use. So when I look back 20 years ago, I want to check whether early results and conclusions when I was really young and my team was really young, when we did not at all have any long-term experience, if these early conclusions have proven over those 20 years and how we went on. One of our first projects we had to deal with was a wood cladding project in Austria, where we had a challenge that we should give a guidance, a practical guidance, how to treat and how to maintain claddings. And the question to my surface group was, how often do we need to repaint a wood cladding? And having no long-term experience, this was really a difficult question for us to give any estimation on maintenance intervals. But what helped us really a lot to collect experience was to visit around 120 different buildings in the northern Alpine region in Austria, Switzerland, and southern part of Germany. And we visited these objects and we looked at the wood claddings and inspected them with a checklist. And the most important part of it was to talk to the building owners about the history of the buildings and their experience and what did they do to retain the surfaces of the claddings. And that was a really, really good collection for us of something like long-term experience, some practical experience from the real users. And we brought together all these data, and as one result of this project, we brought up this table of guidance values for maintenance intervals for exterior wood coatings. First of all, this was a table a little bit smaller than this one for wood claddings only. And this was published in the year 2000 in a brochure for practical guidance, practical use in the year 2000. And around the year 2006, we published another brochure on balconies where we enhanced this table a little bit. We completed this with almost vertical surfaces, almost horizontal inclination of surfaces, which is important for balconies and not so important for claddings, as you can imagine. Over the many years we've been working with service life, maintenance work, and so on, this table was not revised very much, only in a few details, but basically the years we have put here, which was at that time, without having too much experience, quite ambitious, but still up to now, these years haven't changed very much. And we have just re-edited and revised a brochure on maintenance work for exterior wood, published in 2020 in the first edition, in the fourth edition, where we again published this table, and we figured out over the last 20 years it didn't change very much. What are the major factors influencing these maintenance intervals? I want to point out what in the early days of research we were estimating as the major factors. First of all, pigmentation of the coatings. You know, pigmentation determines whether you have an opaque paint where the wood color is completely covered by the coating film, and the light protection is excellent because neither visible light nor UV light can transmit the coating film and reach the wood. Then there is a large group of varnishes, of semi-transparent wood coatings with a distinct color caused by pigments, transparent pigments. And some parts of visible light can transmit the film, reach the wood, and is reflected by the wood so that you can see through the semi-transparent coating film the structure of wood in terms of annual rings, some knots, and you can see the structure. And there is a third field of wood coatings, which is fully transparent systems, transparent varnishes, which appear clear on the wood so that the whole spectrum of visible light can penetrate through the film and reach the wood surface, that you get a real impression of the real color of wood, which is a different kind of additives for transparent UV light protection in these coatings. So these three categories influence durability very much, and I've now put here a system like in colors like green is beneficial and good for durability. Yellow is somewhere in between, some less durability, and orange is like a sign for some attention. You see that we say that in general, opaque paints are better in durability compared to transparent systems, compared to the semi-transparent, and in particular compared to the fully transparent systems, because we have done a lot of research also on transparent varnishes for exterior wood. And after all this research, we still have to say that the suitability of these systems in exterior use is limited. We have figured out just a few good coating systems, a few good products, but roughly you can say any pigmented system is better than the best fully transparent systems for exterior wood. This is really a challenge which has been tried to cope in development work over many years now. And the reason why we need these transparent systems for wood is that wood is such a beautiful substrate, which has beautiful color and structure, because it's a natural grown material grown by trees in the forests. And that's a material that everybody wants to show on the cladding, on exterior wood, to see that the building is really made out of wood. This is not the case if you use an opaque paint. In the early work, we already figured out that bright colors for opaque paints last longer than dark colors. And this is due to a more heat built-up, due to the absorption of sunlight energy of these surfaces, and a quicker tendency to cracking of dark surfaces in exterior use. With varnishes, with the semi-transparent systems, in contrast, we found out that darker pigmentation is of higher durability compared to brighter pigmentation. This is due to better UV light protection. The second very important factor for durability is film thickness. You know that there are different categories of film thickness, from non-film forming, low build coating systems on wood like this one, where the coating film is not continuous on the surface, it's interrupted many times, it's not a closed coating film. Then there is a category of medium build coatings with dry film thicknesses around 20 to 60 micrometers. And then there's the category of high build coating systems. And this is independent from the pigmentation I've shown earlier, because all these systems exist in opaque as well as in semi-transparent coating systems. And we estimated that the higher film thickness has higher durability. That's why it's green here. And the lower film thickness has lower durability. That's why it's orange. And the medium build are somewhere in between, of course. And the third very important factor is exposition. Exposure conditions, you might say. How much is the surface exposed to weathering? And there are a few factors influencing this. This is the geographic region and the altitude, the compass direction, and there we drafted this nice colored compass here, where you see that, and this is valid for the Central European region, where we draft our brochures and recommendations for. In Central Europe, you can say roughly that the main weather direction is from west and southwest, and that's why the conditions are severe in this part of the compass direction. South direction has also the highest irradiation from sunlight. In the east, it's usually medium conditions, medium weathering exposure, because the main weather direction is very seldom from the east side. There is some sun exposure, of course, but the driving rain and moisture conditions are not so severe on the east part. And there are mild conditions in the north facing areas, and because the weather direction is very seldom directly from north, and the sunlight is not so much on the surfaces. But on the other hand, on the north surfaces, have a greater tendency to wet conditions, and that's why sometimes you find more algae and fungal growth on the north surfaces of a building. And the inclination of surfaces is a very important factor for exposition. And with a detail of a balcony, a cross-section of a balcony rail here, you can see that there are top surfaces of the handrail and of the flower tray here, where the top surfaces and also the floor of the balcony, they are inclined almost horizontally with only very narrow or small edges, small angles that the rainwater can run off. Then there are vertical surfaces which are orange here, and there are green parts which are very nicely protected by other parts, sheltered by the decking of the balcony, and therefore very nice protected from direct weathering. So this is the influence of constructive wood protection in the end, which also goes down to detailing of all the wood constructions so that moisture traps and continuous high moisture content is avoided, because that is the reason for onset of decay of wood destroying fungi, which in the end lead to rot and the real loss of mechanical properties of the wood. We've done a lot of work on maintenance, and it is clear that the properties of a new product in the new state are on a certain level, and it's clear that every product in any use degrades because it ages, and this is particularly the case, of course, in direct weathering. And if we now use this table for wood coatings, the coatings degrade caused by the weathering factors. This is commonly known. And there is a curve where the properties go down, and there is some minimum level, which is the minimum for the technical function of the coating. And if we are above this minimum level, there is still some technical function of the coating, and maintenance should work out here. If we now make maintenance, we shift this curve up to a higher level, and then degradation goes again down here. We make some other maintenance and some more maintenance, and we come up here, but we never come underneath a minimum level for the technical function of the coating. This image here on the right side is an example of a sample from a historic wooden window, where you can see a layup of different coatings, which are basically maintenance work done over the last 40-50 years or so. And you see that we found in total 10 different coating layers on top of this historic wooden window. And this is all maintenance done in a stage when the old coating was still in good conditions, because otherwise we would have seen that on the window that the maintenance work didn't really make success. In this case, it worked 10 times, and this layup of maintenance coatings is shown here very impressively. The question is, how often can you do maintenance? I think this is not possible until infinity. You cannot lay up some 20 maintenance coats on top of this surface here because of two reasons. The first one is that the total dry film thickness gets too high. It may be already too high for this sample here. If this is 200 microns, it's about, say, some 600, 800 microns in total here. That's a lot. So the total dry film thickness is one factor. And the second factor is adhesion of coating on the substrate or in between coating layers, as you see here. The loss of adhesion here is really a critical problem because you cannot put a maintenance coat on top, which improves adhesion down here. That's impossible. So in this case, in particular because of the loss of adhesion, degradation has already gone down here under a minimum for technical function, and we need some other work to be done. We must remove the coating down to the area where adhesion is poor, and then we must to renovate, we must to repair the coating and put a new coating on top. The most difficult question in durability and maintenance and renovation work for wood coatings, the most difficult question is, what is the right time for maintenance? When should I do maintenance? When is it too late? When is it too early? What is the right time? And this is really a difficult question, which we discussed with experts in the field, and it's not really clear, and even experts estimate different stages of a wood coating for being the right time for maintenance. That's why we drafted and published in 2011 this table of limit states for wood coatings. We tried to define which defects are acceptable in certain levels. The first level is an aesthetic limit, only optical deficiencies. That means a change of gloss, a change of color, and the growth of algae. These three factors, they don't influence the technical function of a coating. They may influence very much the optical impression, maybe unacceptably, but for the technical function, it's not a big problem. Then there are other defects which determine the maintenance interval, which are minor defects that do not require the removal of the original coating. This is intensive chalking of the surface, cracks in the coating film without visible discoloration around it. That means with good adhesion. Cracks by hail impacts, for instance, flaking in small areas, and superficial mold growth or blue stain growth, so fungal growth on the surfaces, which is just on top of the surface. In this stage, you can remove some dirt and mold growth and fungal growth on the surface, and you can recoat the surface with a maintenance coat and then gain durability with this work. Then there is a renovation interval when cracking, blistering, flaking, and so on occurs in a larger extent, in particular that the adhesion of the coating is lost, which needs removal of the old coating film and layup and application of a new coating system, starting from the impregnation in most cases. And there is another level, a fourth level on durability of the wood. This is the decay of wood. This is the case when brown rot and white rot fungi or wood-boring insects have attacked the wood. This needs completely different work in restoration of buildings and building parts, which is beyond the degradation of the coating itself. In our research work, we focused a lot on the maintenance intervals, on maintenance work, which is based on this definition of limit state of maintenance interval. And that's why I want to elaborate a little bit more on this stage. If we now look at real wood surfaces in natural weathering, the left one is a sample in the original state before weathering, and this is somewhere in between and somewhere in the end of a weathering test. You see different stages of degradation of the coating. There is a brown varnish on top of this soft wood surface, and you see different levels of degradation. And this should illustrate that in this stage, the coating needs regular inspection in some intervals. Some say every year you should take a look at your coated surface. And if you do that and you find defects early enough to repair them by maintenance, then you have really gained durability of exterior wood. So inspection in regular intervals, as long as the coating is intact. There is a small defect, probably by hail impact, with some very slight discoloration around it, and there are a few cracks in this sample. And in this stage, you would need maintenance to retain the integrity of the coating, as long as the adhesion of coating here around this hail impact is not disturbed too much or still in good conditions, you can put a maintenance coat on top of it and retain integrity and prolong the service life of this coated surface very much. But in this stage, there are really heavy defects and adhesion is lost of the coating in many areas here. This would need a repair of these defects, and that's what we call renovation is needed. So you must remove the old coating film down to the solid wood, sand the wood very good, so that all gray surfaces are removed, and then you must build up a new coating system starting from the primer. This is another kind of work, much more demanding, a lot of more effort to do. That's why we call it renovation. If we now look at a series of weathering samples over 38 months of natural weathering, you see different rates of degradation. The first one degrades very quickly, so that after 18 months, you see after 24 months natural weathering, you see really gray surfaces and heavy flaking of the coating system, whereas the last one is still in quite good shape at month 38. The secret is that this is the same coating system with increasing dry film thickness. So this is low film thickness of the same coating system up here and high film thickness here. And we used the definition of maintenance intervals on this set of samples, and we figured out that here on the red rectangles, we found the stage where maintenance coatings would have been needed to retain the integrity of the coating film. And if you look at these stages, you see this is relatively early, where some experts would say, no, we still don't need maintenance, it's still in very good conditions. But if you look in detail, for instance, here on this sample, you see a small crack here, which is a defect that needs maintenance to retain the coating film. Some users and some people would say, I need maintenance here, but by our definition, which has been discussed with experts as well, this is too late for a maintenance coat. This would need a removal of the old coating film and a new coating built up from the primer. We've done a lot of research on durability, as I said before, in these weathering series. And what we've seen earlier in the last slide is this definition and the indication for the need of maintenance needs inspections, visual inspections in very short intervals. And that's why we also introduced measurements of wood moisture content in the interface between the wood and the coating. So just underneath the coating, we put sensors for wood moisture content, and we measured during some years of natural weathering the wood moisture content in the interface. These are three different coating systems. The product is called ICP, which some of you may know from the old standard EN 927 Part 3. This was put on the wood surface with 1 times brushing, 2 times and 3 times brush application. And you see the moisture fluctuations of uncoated wood in the black curve. So moisture fluctuates really a lot. It dries down over springtime here and is a little bit lower in summer and has very high fluctuations. With coatings in general, with intact coatings, these fluctuations are much smaller because of the moisture protection of the coating. And with 3 times ICP, it retained very nicely in a low area of wood moisture content with very low fluctuations. But with 1 time ICP, you see the fluctuations start moving very much during the first half year of exposure, and it comes to the same fluctuations in wood moisture content as uncoated wood from this point in time. So that means here the coating is completely degraded, has no moisture protective function anymore. The next example is a water-based system, again in 3 different dry film thicknesses. The water-based system applied in 20, 50, and 80 micrometers dry film thickness. Here you see that over the first spring period, all coatings were in good shape and good conditions and protected the wood very nicely against moisture. So the moisture fluctuations were low, in particular compared to the uncoated wood again. And then here in June 2009, it starts, the system P20 with 20 microns starts fluctuating more. And in visual inspection, we found out that this was with the occurrence of cracks in the coated surface at the same time. So it fluctuated more, and here the next coating systems with 50 microns started fluctuating more, whereas the system with the highest film thickness had the highest durability. So these measurements of wood moisture content are a really continuous and very good indicator for the need for maintenance of coatings, because it really indicates the loss of technical function of the coating. And it's very interesting results, which we published in 2013 together with experts from other international institutes. How long does a coating last is the big question. And this would either need long-term experience, but the question is how to obtain this and what is long-term experience. It could need long-term weathering, in natural weathering, that you really know how long the coating system lasts, or it could also apply reliable methods for prediction. And the first question here is, if we test in artificial weathering in the lab in short periods, has it anything to do with natural weathering? Is it a vital tool for prognosis of real-life durability? And that's what we investigated in research over some years. We have chosen a nice approach for this, the so-called time to failure approach, where we look for the time until a certain limit stage is reached. And I took this picture of the dissertation of the PhD thesis of Jan Eckstedt. He did some similar things on surface life prediction with water absorption tests, but the principle is shown here very nicely. We look for the time it needs until a certain limit stage is reached, whereas traditional weathering tests look at the samples after 1 year, 2 years, 3 years weathering. We look how long does it take until the coating is degraded and has reached a certain limit stage. The problem here is that it needs much more frequent inspections in short intervals, whereas here you can make every year some assessment of the samples. You need here every month, every 2 months, every 3 months inspection of panels, that you really see the time to failure in a nice resolution. We've done a study with 30 different commercial wood coating systems on spruce wood, where we measured the time to failure in artificial weathering. And this is weeks in artificial weathering. And we did the artificial weathering test up to 60 weeks, which is 10,080 hours, which is more than 1 year of continuous artificial weathering test. And you see that many systems were degraded to the limit state maintenance interval up to 30 weeks in artificial weathering. But there are still 3 systems which were not degraded so far during 60 weeks. So we gave up in the end and said that's enough. So 3 systems remained which were more durable than 60 weeks of artificial weathering. And these 3 systems were all 3 opaque coating systems, whereas the transparent systems have reached the limit state earlier. Interesting groups in this sample plan were 2 variations of the same products. The first one in color, which is this group here, and you see that these varnishes with darker pigmentation lasted longer than the ones with brighter pigmentation, which is seen here. And another nice variation was the film thickness variation of the same coating material, which again gave a nice stepwise behavior in terms of time to failure in artificial weathering. We put the same systems in a 7 years test or 8 years test of outdoor weathering. And again, we figured out the time to failure in outdoor weathering expressed in months. Again, 4 systems did not reach the limit states over 8 years of natural weathering. And again, these were opaque systems, and 3 of them the same opaque systems as we've seen earlier in the artificial weathering test. So in principle, for the opaque systems, which were very durable, the artificial weathering tests selected the best ones out of these systems. The groups of color variation and thickness variation are again shown here. The color variation was not so pronounced here in this test, but the thickness variation brought forward a very nice step here in the results of time to failure. So the question was, is there any correlation? Is there any fit between the results of artificial weathering and natural weathering? And this is expressed now here, artificial weathering time to failure in weeks compared to natural weathering time to failure in months. And this is the raw data. And you see there is some trend. And if you just put a simple linear trend on top of it, there seems to be correlation. But we also bring forward confidential intervals and prognosis intervals of this test, which indicate the uncertainty, of course, of this correlation. But still, I'm confident there is a good tool for predicting and estimating service life of wood coatings. In a few weeks, you can assess how many years it could last outdoors, but I would not say any rule of thumb how many years it would last if you do 2000 hours artificial weathering. This has also been published in 2014, and we extended the weathering from this paper, which are the actual results you see here now very exclusively on this channel and in the European Coatings Journal. If we assess the coating film thickness against artificial weathering durability in weeks, you see over all samples of very different formulation, not so good correlation. But if we just select the thickness variation of the one system where we did this variation, you see excellent linear trend. So higher film thickness means higher durability in a really nice linear correlation. And the same result in natural weathering, where 26 coating systems so far have degraded until the limit state, where again the thickness variation of the same system brought forward a nice correlation. And for all systems, there was at least some trend to this estimation. And this is a result for brightness variation. If we measure brightness on the surfaces, is there any trend for the durability in natural weathering? Well, for the semi-transparent systems with a medium built 20 to 60 microns dry film thickness, we see some rough tendency here that darker pigmentation of these semi-transparent varnishes led to higher durability compared to brighter pigmentation. A more serious approach on service life prediction was made in the large European project SERVOWOOD, involving 5 institutes, 5 associations, and some SMEs, involving 52 coating systems with known formulation, 5 wood species, and so on and so on. And the approach of this project was, again, to find some connection between artificial weathering and natural weathering, and also laboratory testing. But we wanted not just to correlate, we wanted to find a common service life prediction model, a common dosage model for these different kind of exposure tests to be used universally for both approaches. There was also a very interesting natural weathering trial with special setup with these multifaceted exposure rigs, where we could expose coating systems in 9 different directions. And also some of these rigs had additional showers and heaters inside these boxes, that we can also introduce more moisture and more heat. And this in total is a dosage variation in natural weathering, which was the approach of this trial. There is a paper from Laurence Podgorski from last year, where you can read some results on fungal growth of these surfaces. This is just a glimpse of results of one of these setups, where you see the south and west and east facing surfaces, and here the north ones, and this is the horizontal surface on top, with different degradation. In general, you see here with additional water spray, in particular, you see high growth of fungi on the upper surfaces here, much less pronounced on the vertical surfaces, and much less pronounced on the south exposed surfaces. This is the rig with water spray and additional heat. Fungal growth was lower, but degradation of the coatings has proceeded much further, because heat seems to really accelerate degradation, and the samples are in even worse conditions here. From all the results of SERVOWOOD, a factor model for service life prediction according to this ISO standard was drafted, where an estimated service life is calculated from a reference service life multiplied by a series of factors. And the interesting thing here is that the reference service life is the service life of a product which you know very well, where you have real experience from practice. And the interesting thing is that here you can really bring in long-term experience with long existing products and compare them to a development product by applying these factors. And then you get an estimation of service life relative to the reference system. We are currently working on a web-based platform, which is a nice tool for using this SERVOWOOD service life prediction model. It's guided by some texts and a menu where you can fill in some factors for the reference system and for a coating system under development, or which you want to estimate, and then you get multiplied by the factors an estimated service life of 5 years, 6 years, in this case here, 5.4 years. This is just a first screenshot of the web-based tool. As I said, we are currently working on this, and it will presumably be published next year to be used in the practice. And as a last topic, I want to show a few short images of a very recent project on hail resistance, because hail is a problem that really interferes all these efforts we've seen before for service life prediction. Hail is an event which happens at specific weather conditions. Meteorologist says that hail events are increasing in frequency, also in severity. So that was a reason that we here in the Alpine region of Europe, in Austria, were considered with a project on the hail resistance of wood coatings. And you see what hail does to a coating. This is hail simulation on a weathered surface at the beginning of weathering, and then during weathering you see continuous degradation around these hail impacts. And this is a microscopic image of a longitudinal section through a hail impact, where you see a lot of discoloration and fungal growth around this hail impact. We have seen that good primers and systems, including good primers, can really improve the situation very much. They can improve the tolerance of systems to hail impacts for a very long period. As you see here with the system on spruce, there is much less discoloration around the hail impacts after 12 months of natural weathering compared to the same system without primer on the first slide. And in the microscopic section, hardly any fungal growth here in the region under the hail impact. In our research, we have described the degradation and the ongoing development of defects under hail impacts in kinematic images and also with microscopic images. But for maintenance, we found a very important conclusion that, as I said before, maintenance can be done as long as the adhesion of the coating is good. And that's why we suggest in the case of hail damage to use a test like this with a simple adhesive tape, clean the area of the hail impact, stick and rub the adhesive tape on the surface and peel it off. And then you see whether the coating flakes or not, which is an indication if the adhesion is lost, and you can still put a maintenance coat on top of this surface. The reasons why we bring forward this method for practical use is that we found out in our research that the tolerance of coating systems is different for weathering after the hail impacts until the adhesion gets lost. As I've shown you with just 2 examples from our research in the slides earlier, that there can be up to 12-month tolerance of a coating system, that it's still possible to repair it with a simple maintenance coat because adhesion around the hail impacts is still good. It may be with some systems that some weeks or just 1 month after the hail impact, adhesion is lost. But we've seen a few high-quality systems where adhesion was good after 6 months, 5 months, up to 12 months natural weathering after the hail impact occurred. This brings me to the conclusions of my presentation. We have drafted guidance values and published guidance values for maintenance intervals of wood coatings, and we think they have proven in practice, proven in discussion with experts, proven in real-life cases in the field where we have to discuss with real end user customers. We have brought forward limit states for wood coatings. These include aesthetic limits, maintenance intervals, and renovation intervals, and they should help for decisions whether a maintenance coat is possible or the surface needs renovation and repair. We found reasonable conformity of artificial weathering and natural weathering according to the EN 927 standards, and we think a rough prognosis is possible from artificial weathering on the durability in natural weathering. At least you see a nice picture of the characteristics, how a coating system degrades during weathering. The SERVOWOOD factor model predicts service life for wood coatings relative to a reference material, and this reference material brings in long-term experience in the model, which is a very nice approach, and the factor model brings about the possibility to improve the model with consequent research on specific and additional factors later on. And we've seen good progress in the improvement of hail resistance in our research. Even this is challenging. We have found a few systems with good resistance against moderate hail events. And we have also seen systems with good tolerances for hail defects for subsequent weathering. So over these 20 years, we've seen improvements in durability of wood coatings. It improves steadily. Our research work is also confirmed by experience on objects in practice. If you see this building here in 2009, and you look at it 10 years later in 2019, due to several maintenance coatings, it turned a little bit darker, and the coating is less transparent than it was in the early days, where it was really very transparent. But this building is still a successful example of wood cladding and durable wood in exterior use, with a nice impression also for everybody who passes by. You find our recommendations in some publications. Unfortunately, these publications are only available in German language. We've discussed several times to translate them into English, which would be much better, but we have not found a project so far to do so. So that was my talk on wood coatings today. I thank you very much for your attention.
Thank you very much for your presentation, Mr. Gröll, which was very, very in-depth information on your topic. And now let's have a look at the questions from the audience. We already received some. So the first one is there a transparent wood primer?
Yes, I think so. So I've seen a lot of primers which are fully transparent, and then they are covered with pigmented top coats. This is in many cases usual. And there is also the possibility of transparent light protective additives to be used in primers, because for wood coatings, it's not only needed to protect the coating material against the harmful wavelength of light, but the substrate is susceptible to be degraded by UV light. And this is a different situation where you suddenly have to protect the wood against degradation. And there are nice products which include radical scavengers to be used in primers to impregnate the wood with radical scavengers to prevent degradation by light. And in the sector of biocidal products, there are many transparent, not pigmented systems due to the fact that the admission processes are very demanding. And if you then include different colors of a primer, it will be really very expensive probably to get approval for all your color shades of a primer. So yes, I think there is a nice variation, a lot of transparent primers. For wood, as long as they are covered with pigmented top coats, it's a very nice system and can be very durable.
Then to the next question. Okay, I can't download the slides of this interesting presentation. The slides will be available after the recording once the entire webcast is in our media library. You can then download all the slides of this and a very interesting presentation, and there you will also find the contact details of Mr. Gröll, just in case you want to contact him and have some further questions. So then there is the next question. Does the system, waterborne or solvent, have influences on hail or light resistance?
Oh yes, of course. A lot of influences, of course. There are many different characteristics of binders in terms of film mechanics, extensibility, and so on. Light resistance also, but this is mainly steered by pigments, additives, and dry film thickness. It's not much related to the binder of the system. And you know that there are very different characteristics of weathering behavior of coating systems due to the binder system. So this has been a paradigm shift in the times when I really began to study wood technology and to get more involved in wood coatings, when the times were when water-based systems came up on the market and replaced the good old solvent-borne systems. I think today the water-based systems are on a very nice technical level. They are really state-of-the-art, and all small deficiencies they might have had in the early days have been overcome by good research and good solutions. Still, there is in practical use on site, there are of course some difficulties in much narrower tolerances for application, for temperature, for moisture with the water-based systems compared to a solvent-borne system. The trend towards bio-based systems is a bit more related to solvent-based systems today, but very nice solutions also for water-based systems I've seen in some developments. So for me, I don't have a clear preference. I think this is just a variation of very nice and very nicely proven technologies in the coating sector, where solutions in terms of formulation and also application and coating layup are available, which end up in durable and good solutions with both.
And we have the next question. Have you ever tried to evaluate the effect of UV light stabilizers to increase the durability of exterior wood coatings?
Yes, we've done extensive research on UV absorbers and transparent pigments also. So in general, transparent light protective additives. We've done a lot of research on this. Where should I start? Where should I end? As I summarized quickly, it's really a difficult field. I sometimes call it something like the Formula One of coatings formulations compared to the car races in Formula One, where they put a lot of money and efforts in their racing car and try to push it up to the level. This in the coating sector, this is also possible. It has high prices. It's risky, as it is with the Formula One races in car racing. It's an interesting field, of course. There are some physical limitations, for instance, that you would need for filtering of UV light. You would need a coating film thickness. And during the times where we made research on this field, there were some people saying that we have a non-film forming system, transparent, which remains transparent and a nice color over time. But there are some physical limits, of course, and it's challenging, but we should never give up, because it's really good if we could show wood in the natural color on the buildings. I've shown this example of this facade in one of the last slides, or in the last slide, which was originally a transparent coating, and over time, during some maintenance codes, it turned to be pigmented, and in the end, it could be opaque painted surface. Why not? So with maintenance, you could also change pigmentation, add pigmentation, and thereby retain a nice optical view of the building. We don't need to have the demand that this transparently coated surface must retain a transparently coated surface over all the lifetime of the building. This is very, very demanding, of course.
Okay, then what is better? Hulls in the transparent primer or in the top semi-transparent film?
In the end, you will need both, because hulls as a radical scavenger for protecting polymers against degradation by UV light will be needed in the wood to protect the lignin and the cellulose, and it will be needed also in the coating layer to protect the coating polymer. But the pigment helps a lot as well.
And what is your experience with acetylated wood? the same coating has different behavior with normal and acetylated wood?
Yes, we've done some studies with acetylated wood. It works nice. It's a nice substrate. Many qualities are from plantation grown radiata pine, which is traded in Europe. That makes it a very different substrate compared to homegrown softwoods with different structure. So it's a very very beautiful, nice structure with hardly any grain deviations and so on. So from the wood quality, it's the acetylated wood on the European market is very nice. As a coating substrate, we have had one study where it was also good, also in comparison to other substrate. I myself have no real experience if this is due to the modification by acetylation or if it's more like the influence of wood quality of the material we use in this study. But in the end, if I think on the scientific literature on acetylation of wood, of course, the approach is also to stabilize the wood and to make it a better substrate for coatings. And with acetylated wood, I think this works out very well.
Then what can we do to give transparent, almost natural finish?
Yeah, all the questions go around transparent. I think it's the most interesting part, of course. We've done work on interior surfaces for this transparent, almost natural. We've done a project on parquet where we really raised this question. And one important thing was that the surfaces had to be very matte to have a natural look. Any glossy surface of wood has the impression of an artificial, of a plastic-like surface. So I think a very matte surface helps a lot to make it look natural. Maybe I haven't tried this for exterior coating so far. We've only done a lot of studies we've done with additives without varying the matting agents in coatings. But for interior coatings, we got this experience with a study with persons touching and looking at surfaces, and they figured out that a matte surface is very important.
Then a question for the accelerated aging test is with condensation.
Yes, we use the test according to EN 927 part 6. It includes a phase of 24 hours condensation, followed by a cycle of half an hour of UV light, and I think 12.5 or so hours of spray, or opposite, spray, half an hour spray and 12 hours UV light, sorry. It includes condensation as well, and this cycle runs 1 week, and there is another cycle of 24 hours condensation. Every week there are 24 hours condensation in this cycle. You can read it in the EN 927 part 6.
Okay. Then once again, a question that is concerned with transparency. Which system is better for exterior transparent water-based acrylics or solvent-borne 2-pack acrylic?
It's hard to say. You really have to compare. I cannot say it just from these indications. It has got a lot to do with application parameters, layup, film thickness, primer, quality after application. There are so many factors together with additives, so I cannot give just a simple answer to this. As I said before, my experience is that both technologies work and are mature. The 2-pack technology in exterior use is not so commonly used in my region here in Austria and Central Europe. But I think it's promising because you can, of course, apply very different chemistry and other chemical functions in the formulation which are not possible with 1K. It's interesting, but I can't give a clear answer on that. I'm sorry.
Then thanks for the great presentation. Could you please let us know what are the most important test protocols for interior wood coatings?
For interior wood coatings, there are many European method descriptions. The most important is maybe the chemical resistance testing according to EN 12720. But my experience is that there are plenty of national documents for requirements, like in France and Germany and Austria and Italy. You will find a very different application of these standards in the end. So it's really so it has not developed as a European view and European common view on the quality of interior surfaces. And the other thing is that there are great differences between, for instance, flooring and furniture. Furniture having such a variety of different materials, wood species, furniture standards usually also cover other materials like stone and metal, which are just used as a surface in the furniture. So it's really very diverse, but a common ground is probably the chemical resistance test according to EN 12720.
The next question, how do we give a wet look for interior transparent finish?
Yeah, that's very much related to the interface between wood and the coating and the impregnation you use. There have been some studies which relate the wet look to real penetration of coatings into the wood cell wall. This is with oil-based primers, it works very nice. With water-based, there are some difficulties, but I've also seen some nice solutions where I must admire that I don't know the real technology behind. But I think the key is how good do you reach the inner parts of the wood cell wall with the material, which is a matter of polarity and particle size, and if you're able to really penetrate there, then you're good. And also with any fatty product like an oil, you have a nice wet look.
And we have one more comment, which is not a question, just pure comment. Very nice and useful presentation for the contemporary coating world. So that's probably a nice compliment also to your presentation, Dr. Gröll.
Thank you very much for the flowers.
And yeah, we don't have any further questions coming in, but as I already mentioned, the presentation will be available shortly, and where you will also have the possibility to download the slides, and will be provided with the contact details of Dr. Gröll in case you want to get in touch with him and have some further questions. And Dr. Gröll, thanks again for being with us today, and thank you very much. For having you with this very interesting presentation. So have a nice day. Bye-bye.
Thank you very much again for the overwhelming compliments, and also from the audience. Thank you very much for listening, and bye-bye. So ladies and gentlemen, also for us, it's time to come to an end. Thanks for joining us today on this afternoon. A recording of our webcast will be available shortly, as I already mentioned, and we hope to welcome you again at the next European Coatings Live on 27th of October with a focus on waterborne coatings and a presentation by Thomas Bernhofer
of Saint-Omer. Thank you, take care, and goodbye.